Om Swastiastu. Assalamualaikum warahmatullahi wabarakatuh. Shalom Nama Budaya. Hello dear audience. How are you? I hope you're having a good time. Before we start, I'd like to introduce ourselves. My name is GALUH KINASIH. With my partner DIAN OKTAVIANI, we are from KIR 3 Trisma, which represents SMA Negeri 3 Denpasar. This time, please allow us to present the title of our scientific project. The characterization of banana or MUSA PARADISIACA fiber front composite material and snail shell or Pilla Ampulacea powder as raw material for motorcycle body cover. First of all, please let me bring you close to the background of our project. This is a table with types of vehicles that is completed with the usage number of each vehicle starting from 2015 until 2017 in Indonesia. According to the table, the usage of motorcycle remains the highest compared to other vehicles every year. It means that motorcycle is also supporting the rapid development of the automotive or specifically the motorcycle industry in our country. Because motorcycle is supported with some accessories that is also encouraging the growth of this industry. Did you know that Indonesia still imports motorcycle both from the body and engine part from another country? Well, for example, Japan. As it is the biggest automotive producer in the world with some of their well-known companies such as Honda, Yamaha, Kawasaki, and Suzuki. All parts of motorcycle is commonly made out of synthetic fiber that actually can damage our environment in a long period of time, because it is contributing an overwhelming amount of chemical waste and carbon emissions. How about natural waste? Isn't it better if we could utilize it to produce something very useful to replace the usage of synthetic fiber? Particularly when we could utilize it at a high usage number, just like the usage number of motorcycle that could reach the number of hundreds of thousands in our country. This also could lead Indonesia to take a new step forward for developing the automotive industry. Meanwhile, banana midribs are only considered as a waste, which is often thrown away. Not many people know that the waste could be optimized into various materials that have a sale value and can be used as a business, which has very promising advantages. Banana fiber front contains 60 until 65% cellulose that can be used as natural fiber, as it is good for reinforcement and very flex to replace synthetic fiber. Furthermore, one of the ways that has not been utilized properly is the snail shell. It is only become scattered waste that can damage the environment and cause a foul odor. Snail shell contains calcium carbonate that has a potential as a hardener that is widely used in industry. One of a kind is for the motorcycle body cover material. When cellulose and calcium carbonate combine together, it creates something efficient for the natural waste utilization that can be compared to the synthetic fiber, and therefore the research of our science project needs to be done. The aim of our project is to identify the results of the characteristics of the motorcycle body cover prototype seen from the density test, water absorption test, and the gradual heating test. The aim is also to identify the results of the characteristics of the motorcycle body cover prototype seen from the impact test and the compressive power test. Here are some literature reviews. We did this research from the 10th of November 2019 until the 29th of November 2019. And these are some places where we did our research. Well, now please allow my partner, DIAN, explain you more about our science project.
I will continue the presentation from my partner. This is type of research used the experimental research with the composition, and you can see with the slide. This parameter analysis in this study include 1. Density test, 2. Water absorption test, 3. Stepwise heating test, 4. Impact test, 5. Compressing strength test. For data collection methods, we use the experiment and literature study. For material, we use the snail shells, banana fronds, exposed resin and hardener, sodium hydroxide, aqueous, mold release wax, and for the tools, we use the scissors, spatula, jars, blenders, bowls, glass mold, baker glass, ovens, digital scales, brass, impact machine, and bending machine. Next, this is a research design, and you can see with our slide.
Methods of forming the banana fiber fronds. First, prepare the banana fronds that has been cut into small pieces. And then prepare the sodium hydroxide solution for about 15% by using the measuring cup. And then add the aqueous into the cup of sodium hydroxide solution for about 85%. Mix them together. Also mix the small cuts of the banana fronds with the sodium hydroxide and soak it for 24 hours. After the soaking process, filter the banana fronds and dry it. Before the last, open the banana fronds to make it easier to be blended with a blender to get the perfect banana frond. Methods of forming the snail shell powder. First, prepare the snail shell that has already cleaned and dried. Open the snail shell with a heat of 800 Celsius degree for 2 hours and wait for approximately 12 hours to be cooled at room temperature. Crush the fragile snail shells using a blender, and then the snail shell powder is ready. Prototype making methods. First, measure the mass of all the ingredients with different ingredient ratio for each prototype. After measurement, mix the banana fiber frond and snail shell powder and then stir it until evenly mixed. Next, add the epoxy resin and stir again, then add the hardener and stir until it blended all together. Pour into the mold that already contains mold to form the prototype. Wait to dry for up to 24 hours. Remove the product from the mold carefully. We'll get the prototypes done. Prototype characteristic testing procedures. First, density test. Testing is done by calculating the mass and volume of each treatment. The way to find mass is to weigh the sample using a scale, while the way to find the volume is to calculate the length, width, and thickness. Impact test. This test is carried out to determine the magnitude of the impact power price and the tenacity of the binding and composite matrices. The impact testing machine used in the study is named Sharpie. Water absorption test. Each sample is weighed to determine the weight before dipping it in water. Then the sample is dipped into a measuring cup containing 400 milliliters of water for an hour. Stage warm-up test. Each sample is in an oven with 4 waves, where the first wave with a temperature of 1,100 Celsius degree for 10 minutes, the second wave with a temperature of 1,400 Celsius degree for 10 minutes, and the third wave for 1,700 Celsius degree for 10 minutes, and the last one is for 2,000 Celsius degrees for 10 minutes. Compressive power test. Each treatment was measured with length, width, and thickness respectively as follows: 140 millimeters, 10 millimeters, and 5 millimeters. Next, Place the sample on the edge of the mat. After the midpoints are aligned, then a pressure or test can be carried out. Turn the controller to move hydraulically downward to press the sample.
For result of the research, based on the result of the density test, P1 has 1.213 gram per cc, P2 has 1.242 gram per cc, P3 has 1.293 gram per cc, and K-min has 1.08 gram per cc. For the result of the water absorption test, P1 absorbed 0.38%, P2 absorbed 0.09%, P3 absorbed 0.21%, and K-min absorbed 0.08%. Judging from the granular heating test result with a temperature of 110 Celsius direct until 200 Celsius direct for 10 minutes, all product can still withstand the original shape. Based on the result of the impact test, P1 has 0.003 Newton per square millimeter, P2 has 0.004 Newton per square millimeter, P3 has 0.0024 Newton per square millimeter, and K-min has 0.001 Newton per square millimeter. For the result of the composite power test, P1 has 50.17 Newton, P2 has 62.18 Newton, P3 has 45.26 Newton, and K-min has 32.88 Newton, and this is a composite power test card. Calcium carbonate contains CaO or calcium oxide and CO2 or calcium dioxide. When CaO is mixed with the motorcycle body cover, it will be experience hardening through flowering crystal to minimize the senorate that occurs if the motorcycle body cover begins to dry. In addition, the presence of 60 until 65% cellulose in the banana fronds has the potential to be a reinforcement in composite because of its high crystallinity. The conclusion for our research: 1. The composite has a density between 1.213 until 1.06 gram per cc, with the lowest result P1. All composites have low water absorption power of 0.08 until 0.38%. Judging from the granular heating test result with a temperature of 110 Celsius direct until 200 Celsius direct for 10 minutes, all product can still withstand the original shape. 2. The result of the impact test, the best product is in P2 with a value of 0.004 nanometer per square millimeter. The result from the power press test, the best product by P2 with a value of 62.18 Newton. Suggestion 1. Further research is needed on the strength and printing of the motorcycle body cover in order to be able to apply it in the wider community. 2. People are expected to create their own motorcycle body cover through banana front waste and the snail of sail, which is a waste that is always around them. And this, our reference you can see with our slide. That's all our presentation. Sorry if there is a wrong say. Thanks for your attention, and we close with the Paramasanti. Om Santi 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 Om.